All right, so in 4.7 we talked about transformations of exponential functions and log functions, which include e and include ln, because that's the log base e. So it said to graph, and then you find the asymptote, describe how the graph is transformed from the graph of its parent function. Okay, so let's start there. So describe to me what transformations are happening with 2 to the negative x minus 1. This is going reflecting over the y. And this minus 1 is doing what? Good, shift down 1. So if you could picture just your simple 2 to the x, so there's 2 ways to look at the graphs of this. One is graph the original function and then shift it. The other is plug in points. So if I were to do the first one, let's say I'm going to graph 2 to the x. Then I can do -2, -1, 0, 1, 2. Okay, and plug those points in. So 2 to the -2 is 1 over 2, which 1 over 2 squared, which is 1/4. 2 to the -1 is 1 over 2 to the first, which is 1 over 2. 2 to the 0 would be 1, 2 to the first would be 2, and 2 to the second would be 4. So this parent function would look something like this. That would be the parent function, right? Which is, what's it called? Growth or decay? Growth, right? And I know that because the base on that is bigger than 1. Okay? Karina.
Like where you inputted the points, doesn't the -2 and negative x
So I'm doing the parent function and then shifting it. There's 2 ways to do it. One would be the way I'm going to do it this first time, and then the other would be to plug in the points to the actual function. So I'm just show you a different way to do it. There, you can do either one. So now if I were to take and shift these points, right? So up or down 1 and then flip it over the y means it's going to reverse so that it now looks like this. And then shifted down 1 means it's going to move. So all these points would move down to here. So that's one way to graph it, is use the transformations. Okay. So that final, I've done it in different colors. This would be the graph of 2 to the negative x minus 1. The other way to do it is to plug it directly into this. So if it's talking about transformations, then you can graph it either way. If you wanted to actually graph that to the negative x, that's when that would happen. So that's -2, -1, 0, 1, 2. If I did 2 to the -2, that becomes 2 to the +2, which is 4. So my -2 should have been at 4 if I was doing this exactly instead of using the transformations. Okay. -1, 2 to the -1 is 2 to the first, which is 2. So -1, 2. 0, 2 to the -0 is just 0, which is 1. And 1 minus 1 is 0. 2 to the -1 would be 1/2, which is where that kind of point is there. And 2 to the -2 would be 1/4, which is that point there.
Interruption, but the Italian students, as well as our Archbishop McCarthy students, please report to the Office of Student Services, ALAB, Italian students, and their accompanying Archbishop students. Student Services, thank you.
So like I said yesterday, you're not actually going to be physically graphing that on the test, but you should be able to look at that function and describe the transformations. So if I gave you f of x equals 2 to the -x minus 1, you would need to describe to me that that's reflected over the y-axis and then shifted down 1 place. Okay. Questions?
So the graphing is not on the
So the graphing is not on the test. Mm-mm. Other questions? Yep.
Why did you put 2x on top of the x?
For this one, you mean?
Yeah.
So that's the first way to graph it, is graph the parent function and then shift it. So we took that's the parent function without any shifts. And then we could have taken that, flipped it so that it faces the other way and shifted it down 1 place based on the transformations. The second way to graph it is literally plug into that function. But when I got those points, it should be similar to what our transformation would have been, which is flipping it over and shifting it down 1.
And do you always have to do both?
No, it's just,
Choose which one you do?
mhm.
Okay, that one easier, like to negative x.
Usually plugging them in is going to be easier. The good thing about understanding the transformations is when you go to plot that, it confirms that it should look like it does. All right, so then the second one says, write the transformed function ln of x is stretched by a factor of 3. Oh, that doesn't say. Let's say it's vertically stretched by a factor of 3 and reflected across the x-axis and then shifted 2 units left. So the first thing, stretched vertically means what? Where's that stretch shown? Before the log or inside the parentheses? Before the log. So that's a 3, right? And if it's vertical stretch, it stays true. So this could be like g of x equals 3. And then ln of x would go here. So then the next thing I have to look at is reflected across the x-axis. So across the x, is that on the front or is that inside? In the front. So this is a negative 3. And then the last part is shifted 2 units left. That happened inside the parentheses or after the parentheses? Inside. So now I'm going to get rid of this parentheses. And I'm going to say this is a plus 2 inside the parentheses. So g of x equals negative 3 ln of x plus 2. And actually the parentheses could go here. Okay, so again, horizontal shift would be inside the parentheses. Vertical shift would happen after. Questions on any of that? So you want to be really familiar with your transformations, obviously, because it's going to ask you, and it will either be exponential or it will be log, but they're all the same, or an ln, or an e. They're all the same, okay? So first thing you want to do is make sure you have calculators, okay? And they can be graphing or they can be scientific. Doesn't matter which one. Okay, so from 4.7 or 4.1, really the only thing here was the growth decay model. So it's going to give you, just like the quiz did, it's going to give you the description and it's going to ask you to form a growth or decay equation and then identify if it's growth or decay, okay? So you want to look for words like increased or decreased, appreciated, depreciated, a growth or a loss, anything like that to determine if it's going to be an increase or decrease. So let's say you buy your iPads, okay? So if you buy, student buys $1,500 iPad, that depreciates. It's got a lot of storage. 15% each year. Write a function to model. Okay. All right, so the first thing to do is actually set up the function. So a student buys $1,500 iPad that depreciates. So does depreciation mean a positive change or a negative change? A negative change, right? It loses its value. So when you set it up, I'm going to take that $1,500 or my initial investment, multiply it. This is 1 plus or minus the rate. In this case, it's a minus, right? Because we're taking away. And that rate is 15%, but I can't write a percent in an equation, which means I have to do what to that? Make it 0.15. And it be raised to the t, which is each year. And then I just want to go one more step and take that 0.15 away from 1. So this would be 1,500 times 0.85 raised to the power of t. And there's my function. okay? And then again, identify if it's growth or decay, and we just said that this is what? Decay, right? It's losing value. Questions so far? So you don't have to graph it, you're not finding the value, you're literally just doing the setup of it. That's it for 4.1, yep. 4.2, which was inverses. And actually, I don't even think there's a question from 4.2. We're going to go straight to 4.3. Oh, that's not true. There is inverses. There's no graphs of them, but you do have to find the inverse. So if I had y equals 1/2 x minus 7, and you want to find the inverse. Okay, so the first thing you're going to do here, and these will actually be written as f of x, not y. So the first thing I'm going to do is change f of x to y. Then I'm going to switch the x and the y. Because that's how you find the inverse of something, right? If I gave you values, I gave you x, y values, then you would switch them. Okay, then I want to solve for the new y. So how can I get that new y on the side by itself? What's the first thing you would do? Add 7. And then, good. So I get 2x plus 14 equals y. And then the last thing I need to do is substitute f negative 1 of x back in for y. And that's an important step that some of you skipped on the quiz, so make sure you do it. So this is f negative 1 of x equals 2x plus 14. Because y does not equal 2x plus 14. Y equals 1/2 x minus 1. But the inverse to y, and the way we show the inverse, is the negative 1. That's how you indicate that you just found the inverse. So there's a couple of questions on inverses, so you need to make sure you know how to do those. Okay, obviously how you solve for y is going to be different. Okay, then we got to 4.3. So 4.3 was logs, the introduction into logs and exponential form, which laid the foundation for everything after it, okay? So you will get super easy questions just going from one form to the other. Don't screw it up, okay? These are good, easy questions. So if I have log base 5 of 1 equals 0, and I ask you to get this into exponential form. Good. All you got to do is take the little guy, come across the equal sign, pick up the one that's by itself, and ditch the 1. Remember, they never stay together. And then vice versa. If I had 3 to the negative 2 equals 1/9. Now we're in exponential form, and I want you to put it in log form. So that 3 is the base on the exponential function. It becomes the base on the log, and the base on the log is the little subscript number. And then remember, they split up, so that negative 2 doesn't stay with the 3. The 1/9 comes across the equal sign, and the negative 2 goes to the other side. So you will have questions as easy as that. You just have to remember how to get from one form to the other. And these are ones, unfortunately, that you're not going to get much partial credit, so you want to make sure you're careful. total? That's actually a good question, I have to look at it. I forget. Any questions on going from one form to the other? Because that was basically all you did in 4.3, and then sometimes there's the simple ones that you can actually simplify. So if it said to get it into log form and then simplify, or simplify using mental math. So if I didn't have the left side, if I just had log base 5 of 1, and it said to simplify, this is something you would automatically know is 0, okay, right? Because if what power I have to raise 5 to get to 1? 0. How about log of 5 to the 1/25th? What do I raise 5 to get to 1 over negative 2? So you're saying what power do I have to raise 5 to get to 1/25th, right? So I got to get it negative so that it goes to the bottom and then raise it to the power of 2. It'll say either switch it from one to the other or simplify if possible. So it states it pretty clear. Questions on that one? Okay, then we got all right, so properties of log. So there's two ways. There's condensing and there's expanding, right? So if I have more than one log and you're putting it into one, that's called condensing. So the first one we're going to do is condensing. Okay, and so for these, if I have log of 5 of 1 plus log of 5 of, 25, and I want to write them as one log. So when I add and I condense, what happens to the big numbers? I multiply them. So this would become log base 5 of 1 times 25. And if it says and simplify if possible, this becomes log base 5 of 25. And that would become what? 2. There is none. The little number is the base. The other number is not really. It's so you read that as log base 5 of 1. Okay, then the next one would be subtraction. So if I'm trying to condense this and it's subtracting, that becomes what? When you subtract, you divide. So this would be log base 5 of 1 over 25, which we just said was good, negative 2. And then the last thing is if let me change that one. The last thing is if there's a number on the front and I want to condense this, what happens to that number on the front? It becomes the exponent. So this would become log base 5 of 2 to the third. Okay, and I can simplify this maybe one step further, log base 5 of 8, but then it would stay that way. So 3 ways to condense. Adding becomes multiplication, subtracting becomes division, and the number on the front becomes the exponent. Okay, then we had stuff like, oh, Ian, you have a question?
Yeah, can you explain it already?
With the last one?
Yeah.
So if there's a number on the front and you're expanding, or you're condensing that, that number becomes the exponent on the 2. So there's just 3 different properties of condensing and expanding. Addition becomes multiplication, subtraction becomes division, number on the front becomes the exponent. And then you're going to see a couple where like you might be able to do, again, like mental math where we've worked out stuff like if it was log of 10 to the second. So I could go a long way around this, and I could say that 10 to the second is 100. And then if there's no base written there, what's that little number? 10. And it would be 2. Or remember, if the base and the big number are the same, I can cancel them out and keep the exponent. So there's a lot of different ways to look at that. If I wanted to expand it, that could come to the front. 2 log base 10 of 10. Log base 10 of 10 is 1, and that becomes 2 times 1, which either way becomes 2. So there's a lot of different ways to look at these when you start dealing with your properties, and whatever makes sense to you is what you want to do. Questions so far? Okay, and then you're going to get one with dealing with the change of base, which is when the numbers are not the same, but you've got your calculator to figure it out. So if I had log base 7 of 12, and the directions will say simplify and round your answer to the nearest, I think it's 2 decimal places. So you should know that means that I've got to now put this in the calculator and use the change of base. So if your calculator actually allows you to change your base, then you can just go straight there and do it. If it doesn't, then this becomes log of 12 over log of 7. So the directions here would say simplify, and it will say round to the 2 decimal places, so that it hopefully reminds you that that's when you need your calculator. Or it'll say evaluate and round.